Welcome to The Explainer. All right, let's talk about something that's been a massive buzzword for years, the microservices architecture. It was promised as the solution to all our big software problems, but as we're going to see, it also brought a whole new world of headaches. So today we're going to unpack not just the what, but the really critical question of when. When is it actually the right choice?
Okay, so here's our game plan. First, we've got to look back at the old way of doing things, that monolithic wall, to really get why we needed something new. From there, we'll jump into the big ideas behind microservices, the core principles, and even some real-world patterns. And then, we'll hit the big one, the trade-offs. This is where you figure out if this is all worth it for your project.
So first things first, you can't really appreciate microservices until you understand the world they came from. We need to talk about the monolithic wall. This was the go-to way to build software for a long time, but as applications got bigger and more complex, some serious cracks started to show.
And this brings up a really good question, right? If it's not broken, why fix it? I mean, monoliths powered huge companies for decades. And the thing is, they weren't exactly broken. It's just that the game changed. Suddenly, businesses needed to move faster, scale bigger, and build systems that just wouldn't fall over. And that's when the old way started to feel, well, really old.
It really all comes down to the trade-offs here. Think of a monolith like a giant, tangled ball of yarn. Everything is connected. So if you want to change one tiny piece of code, you have to retest and redeploy the entire ball of yarn. It's slow, it's risky, and if one part breaks, the whole thing can just unravel. Microservices were born out of that frustration. The idea was simple. What if we could untangle that ball into a bunch of small, independent spools of yarn instead?
And that idea, it's really a whole new philosophy. It's not just about, hey, let's make things small. No, it's a completely different way of thinking about where the lines in our software should even be drawn. So this is what that world looks like. You've got this whole collection of services, each doing its own thing. They're basically independent little applications that talk to each other over the network. And here's the absolute key to the whole thing. Each service owns its own data. No sharing. That's what gives them their true independence.
So how do you decide where to draw those lines? Well, the main idea is something called a bounded context. It sounds super technical, but the concept is pretty straightforward. It just means each service should be an expert in one and only one part of the business. You've got a service for payments? Great. It knows everything there is to know about payments and absolutely nothing about, say, shipping. It's a specialist. And that's why this quote from Martin Fowler is so spot on. The name microservice can kind of throw you off. The goal isn't to make things tiny just for the heck of it. The real goal is to get those business boundaries right. If you do that, the service ends up being the right size. Not too big and not too small.
Okay, so this philosophy of drawing sharp lines in the sand brings us to the most important technical idea in this whole explainer, radical decoupling. I mean, we're talking about making these services truly independent. And to do that, you have to follow some very strict rules. Rules that can be pretty tough to stick to in the real world.
And here it is, the number one rule. The one that's often the hardest for teams to follow: data isolation. Each service gets its own private database, period. No exceptions. No peeking into another service's data. This is so important because it stops them from getting all tangled up at the database level, which is a classic monolith trap. It means the team working on the user service can switch their database, and no one else even has to know.
Okay, so if every service is its own little island, that creates a new puzzle, right? What about stuff that everyone needs, like logging or security? You don't want to reinvent that wheel in every single service. Well, there's a really clever pattern that solves this exact problem.
It's called the sidecar pattern, and the name is perfect. Think of a motorcycle with a sidecar attached. The main service is the motorcycle. It's focused on its one job, its business logic. And then you attach this little sidecar right next to it, and that sidecar handles all the boring but important stuff, the operational plumbing like logging and monitoring.
And here's what makes it so powerful. You can have a dedicated team build and maintain this one sidecar. It has all your standard tools. Then you just deploy it alongside every microservice. So check this out. When you need to upgrade your monitoring tool, you don't touch dozens of different services. Nope. You just update the sidecar, roll it out, and boom, everyone gets the new functionality. It's brilliant. You get to share code without messing with that precious independence.
This whole theme of independence also changes how services talk to each other. We tend to move away from orchestration. That's where you have a central boss, like a conductor, telling everyone what to do.
Instead, microservices prefer choreography. It's more like a dance floor. One service just announces, hey, an order was placed. And any other service that cares about that, well, they just react. The inventory service hears it and reserves the stock. The shipping service hears it and prints a label. There's no single point of failure, which is awesome for resiliency.
Now, this all sounds pretty amazing, right? But, and this is a huge but, none of this is free. Not even close. This is where we have to talk about the trade-offs, because microservices are absolutely not a silver bullet. You really need to go in with your eyes wide open.
In this slide right here, this is perfect. It's like a report card for microservices. It shows you exactly where this style gets an A+ and where it's, well, pretty much failing. And that's the life of a software architect, isn't it? It's never about finding the perfect solution. It's always about picking the right set of trade-offs for your specific problem.
So let's start with the good stuff, the 5-star ratings. These are the superpowers, the big selling points, the reason people get so excited about this architecture in the first place.
And it all comes back to that independence we've been talking about. Look at these. Elasticity? That means if your checkout service is getting crushed during a big sale, you just scale that one service up. Deployability? Your inventory team can push out 5 updates a day without anyone else even noticing. And fault tolerance? If your non-critical recommendations service goes down, oh well, people can still buy stuff. The whole system doesn't crash.
Okay, deep breath. Now for the reality check. Let's look at the other side of that report card, the 1-star ratings. These are the painful parts, the things that can really bite you if you're not ready for them.
What these low scores are telling us is that microservices are not simple and they are not cheap. Here's the secret. The complexity doesn't just vanish. You're trading in the code complexity for operational complexity. Now, instead of one big application, you have a whole network of tiny applications you have to manage. That's a distributed system. And that requires a ton of automation. Oh, and performance. Every call between services is a network hop, and that's always going to be slower than a simple function call inside one machine.
So you've seen the incredible highs and the pretty serious lows, which brings us to the million-dollar question. How in the world do you decide if microservices are actually the right move for you and your team? Well, you should start thinking about it if you find yourself ticking these boxes. Do you need to scale different parts of your system independently? Do you have a burning need to ship updates super fast? Do you have a bunch of teams that keep stepping on each other's toes? If you're not in your head, it might be a good fit. But look at that last point, the one about a strong DevOps culture. That is not a suggestion, it is a prerequisite. If you don't have the automation and the operational know-how, you are going to have a bad time.
Ultimately, after all of this, it really just comes down to one single question. This is the big takeaway. Does the complexity of your problem justify the complexity of this architecture? Because remember, microservices don't get rid of complexity, they just move it around. And if you can answer that question honestly, you'll know exactly what to do.